right, let's watch our thing here. We got people doing the donut thing here. It's all right. This is, I'm gonna run you guys through some real world repairs. I got this from an email blast that I get every so often, some of this stuff. And we're gonna see if you guys can figure some of this stuff out on the way through. Now this is engine performance issues. This is what we do. We have a vehicle. It's a 2006 Dodge Ram 1500 four-wheel drive, 5.7 VIN 2. Mileage 94,587 miles. Vehicle had diagnostic trouble code faults. PO 335 for crankshaft position sensor, PO 642 for sensor reference voltage 1 circuit low, and PO 2122 for accelerator pedal position sensor circuit, and the engine also lacked power. Okay, this is what we're starting out with. These are the codes we got. We got symptoms of lacking power. We've got these codes that we're getting. The technician finds a wiring diagram included with the PO 642 DTC diagnosis chart. All three codes could be set by the sensors residing on the same circuit. Accelerator pedal position sensor, crankshaft sensor, throttle body. All of these right here. The powertrain control module feeding a 5-volt supply out to those sensors right there. So he's noticing all these. You got to physically find those sensors on the vehicle and all that. So he tested the circuit to verify the 5-volt reference. The pink yellow wire, which is supposed to have 5 volts, only was showing 1.6 volts at the PCM. And he thought one of the sensors could be shorted, so he disconnected all of them. He unplugged all the sensors, but the wire was still reading 1.6 volts. Okay? Talk to me. So we're throwing an $850 PCM on it. Okay, he's just joking. All right. What do you think? This guy, he's in it, man. He's in it and he's got to win it.
So it's supposed to be getting power from the references.
Is the battery dead?
No. Battery's not dead. He disconnected the pink yellow wire from the PCM. Now there was 5 volts coming out of the PCM, so he disconnected it here, and he found 5 volts coming out of the PCM.
The PCM working.
When he plugged, huh?
The PCM working.
Oh yeah, there's nothing wrong with PCM. See, this is the kind of thing we do before we throw an $850 PCM on it and find out that we misfired on our diagnosis, and now everybody's mad, and the parts department won't take it back, and you know, this kind of thing. So you make sure that you do that right first. You got 5 volts right there. What was the wiring diagram not telling him? Remember when we talked about wiring diagrams? Sometimes they don't tell you everything. They leave out important information. This particular one, he used the wiring diagram, locates the engine oil pressure sensor that was also powered up on the same circuit. Now this is not the switch that turns on the light or operates the gauge necessarily, although sometimes it'll be networked through the computer. This is a 3-wire sensor. We have replaced 2 of these in here on chargers with 5.8s. Quincy had one, and there was a Cynthia's vehicle, that black, dark blue Charger with a 5.7. It had the bad engine oil sensors in it. Once the engine oil pressure sensor was replaced, the technician cleared the codes and road tested, and all the monitors were complete, and the problem was corrected. He had a sensor that wasn't shown on the engine controls diagram. It was giving us a problem. See this right here? He went and found another wiring schematic. You got to keep digging. You don't just feel like this wiring schematic's the only one. In that same shop manual, he found this place over here, oil pressure signal. Now this one here says accept 5.7 light duty. That's the SRT 5.7 light duty. And see this? Look there. We got reference voltage on this pink yellow wire. It's also going to these other sensors. This sensor here was not even in the picture to begin with. That's a problem, isn't it?
So that's a bad design.
Huh? Well, it was not a bad design. It was a bad wiring schematic. The design was that all of the sensors, 3-wire sensors that this computer talks to, have 5 volts going to them. Any one of them can be shorted and cause you some serious grief.
That's what I'm saying. Like, if any one of the sensors go bad, it messes up everything.
Well, you're going to have 5 volts going to the sensors if you're going to get a signal from them. But you've also got a mechanic that knows what this guy knew, is that there's a sensor somewhere that I'm missing. On the Fords, a lot of the sensors that are, when people forget about that and they wind up with a sensor shorted to ground, the fuel tank pressure sensor in the gas tank's got 5 volts going back there. You can have a short in the ground back there. You got no scan tool communication, no fuel injection. Engine controller is dead, won't talk. If your scan tool won't talk, you better put the scan tool down and go looking for issues. Find out if you got 5 volts. If you don't, start unplugging 3-wire sensors until it comes back. Or look for a short on that line. You can use a plain old test light and look for a short on that line if you got the PCM unplugged. Hook your test light up, see if that 5-volt line shorted to ground. If it is, you find out where it's been pinched or where a screw's been run through it or something. He changed the sensor right here. You remember the one, some of you guys did this, you gotta reach way down there below the alternator, you gotta pull the alternator off actually, and screw that thing out. Now there's another oil pressure, for the oil pressure indicator on the dash. This is so the computer can maintain and it seemed like Quincy had one that said he had the wrong oil, he had a code for that.
I
We put this,
all this sensors, current sensors, oil pressure
yeah,
sensors.
but I mean, he came back later and it was giving him a reading saying he had the wrong oil in it or something. We put that sensor on there, and anyway, he changed that. So, let's go on with another one here. Here's a 2002 GMC Envoy 4-wheel drive L6 4.2 VIN S, mileage 136,000. The vehicle stalled only when activating the left turn signal. The right turn signal, it didn't stall. The left turn signal, it did. The customer also noticed the left headlight was dim. Okay? The customer replaced the headlight, but there was no change. The stalling problem began to get progressively worse until it happened all the time. Anytime he turned on the left turn signal, it would die.
All the wires on the left side are bad.
Okay? So I go into the parts room and say, okay, I've got this done. This Envoy, I need all the wires on the left side. You gonna buy those? You gonna go to the parts room and say, I want all the wires on the
I'm
left
pretty sure they're gonna cross the
Yeah.
right side.
I can't really go there. All right, the technician found 2 volts using the ground circuit of the headlight and a left turn signal for reference. So both components are grounded at the same location. Is this maybe a problem here? Okay,
Yeah.
it's located on the engine block. Although the ground looked good and tight, the bolt was corroded and a little rusty. The wiring diagram showed the fuel pump relay coil also grounded at the same location. That's interesting, isn't it? All right, so
I think it's
the
got-
fuel pump relay coil is getting the ground through the through the turn signal bulb.
When it turns on the turn signal, it pulls too much load. and-
Well, it actually neutralizes most of the ground that the fuel pump
That's what
relay
I'm
was
saying.
using, and so the fuel pump quits running because the relay drops out when he turns on the turn signal. Now, as these things come up, watch this. There's your park turn signal lamp. There's your left high beam. They're getting the ground from the same place, G107. This is what you need to be looking for. Common grounds and common powers and common connectors. See what I mean? That's how you're gonna find the stuff that everybody else couldn't find. Here's another one. See that? Same ground. And here's your fuel pump relay schematic. See that? There you go. So basically, this is what ground distribution schematics, that ground right there. Now, I will tell you, I don't like the fact that some of these people that draw wiring schematics or some of these outfits, some of these wiring schematics are drawn by computers. But this particular one shows the ground coming in from the bottom, but it loops over on the top, and then the power that, I don't like really the way that's drawn. One way or another, we had the same ground feeding all 3 of those. So if you've got 3 different symptoms, you turn on the turn signal, you got a dim headlight, and the fuel pump relay drops out, start looking for common grounds. Everybody clear on that? This is good for electrical, good for electronics, I want electrical too, and all that. Confirm repair, he wire brushes the contact point on the engine block, replaced the bolt and washer, the headlight was now bright, and the stalling problem with the left turn signal was also resolved. 2001 Pontiac Grand Prix V6 3.8 VIN K automatic transmission, mileage 138,446. It came in the shop with a DTC P0404, which set right away after clearing. He noticed the engine stumbled on mild acceleration. All right, now the EGR valve could be commanded open with a scan tool. If you tell the scan tool to open the EGR valve, these EGR valves like on these GM cars have got 5 wires going to it. 3 of the wires are a sensor, got 5 volts, got signal, you got the 5 volts, you got the signal return, you got the signal, and then the other 2 operate the EGR valve motor. So you can actually go in there and monitor the EGR valve position, and you can tell the scan tool to open the EGR valve to see if it actually moves. That's basically what it's doing that. Okay. He removes the EGR valve and inspected the port. Well, the engine only stumbled at idle when commanded to 60%. See, this is telling him, this thing should be flowing EGR before 60%, right? So he removed the EGR valve and inspected all the ports were clear. He didn't have any clogging in his EGR ports. Scan tool pin information showed the EGR position voltage was only 1.75 volts when the valve was commanded to the wide open position. So the voltage at the sensor, see, and whenever he's looking at the voltage on the scan tool, he wants to measure the real voltage at the sensor to see if they are given the same reading. That makes sense? Okay, so he went ahead and checked that. This guy's covering his bases. You know what I mean? He's not just going to the customer and says, you need to buy this and you need to buy that. You know what I mean? He's basically checking to make sure that when he makes a repair, he's done it the first time. All right. 2001 Pontiac Grand Prix confirmed repair. The technician replaced the EGR valve. And there's what the EGR valve looks like right there. You've seen those before, right? That's not a fuel pressure regulator. That is an EGR valve. Basically, the position voltage reached 4.25 at the wide open position. Now, what was going on here was when this thing commanded the EGR to open, it was looking for a particular voltage here. The position sensor voltage, it was looking for a particular position sensor voltage, and this couldn't read any higher than 1.75 volts, and it wanted more than that. And so what it was doing was it was slamming the EGR valve all the way open, and it was causing it to fall on its face. Because EGR does what? Makes it run not good, right? Whenever it's anything except, but if you get too much EGR when you're accelerating, it's going to fall on its face. And this is what was going on here. Now see, this was a surgical repair. He didn't say, we're going to change this, and this. He's actually doing all this troubleshooting. That's kind of like what me and you were doing at Chevrolet truck. We were trying to get, you know, we changed the stuff we knew we needed to change because the spark plugs were the ones that came in it. You know, we didn't like that. So you say, if this thing's got 134,000 miles on it, it's got original spark plugs in it because they got a paint spot on top of them, it's not a bad idea to replace those. And we just kept chiseling along there. We actually did a bunch of extra work to try to make sure we didn't sell them that they didn't need. All right, so the DTC was cleared, the vehicle was test driven, the problem was resolved. In an OBD1 onboard diagnostic 2 system, when all the enabling criteria for a given diagnostic is met, which of these terms describes that? Whenever all enabling criteria for a given diagnostic is met, it's considered what? Freeze frame, turned up engine, warm up cycle, or trip?
Trip.
That is a trip. Basically, whenever you've actually gone out there and see, you got to have to measure your catalytic converter efficiency, you got to have it at a certain speed for a certain amount of time and everything. And there's other things, there's other monitors that won't run. Evaporative temperature, the evaporative system won't do its test unless it's got certain criteria that are met and all that kind of thing. All right, 2000 Buick LeSabre Limited 3.8, mileage 172, 347. Starting, and this guy says, the guy that wrote in says, the start of this vehicle reminds me of the days of distributor caps and rotors. It has excessive kickback and runs very rough when it finally starts. It's also backfiring in the intake. When it does start, there's a very strong sound of intake air initially. You ever heard that sucking sound in the intake? All right, once it runs long enough, it goes into closed loop, everything straightens out, and it reacts normal. Acceleration and performance are good. And see, the problem these people have, whenever it warms up, this is always okay, but when they first started, it runs terrible. All right, so what are you thinking?
What was that thing I was messing with the other day on that car? On that car that had that idle, that weird idle?
Oh, the throttle body?
What was the sensor I was messing with?
Oh,
I can't remember what it's called.
you ain't talking about the mass airflow sensor. What are you talking about?
One of the idle positions.
Throttle position sensor? Yeah, well, no.
It sounds like it's kind of vacuum leak until, like it goes in
But
closed loop.
why would it kick back? You know what I'm saying? It kicks back like, you know how it sounds like when you got it out of time? Boom. It's kicking back and trying to destroy the starter. One time I crossed a couple of plug wires on that Mercury Sable because I was going to bug it. And the first time I went to start it, it goes, whoa, whoa! It made a noise, and I went in there, and the starter was hanging by the wires because they had busted the nose off. That was funny. You know, but imagine that if you cross a couple of plug wires and you bust somebody's starter, you know, who buys a starter, you know? It's kind of like the, you know, the register. Anyway, Many parts have been replaced on this vehicle. Mass airflow, throttle position, crank positioning, cam sensor, IAT, PCM wire harness to ignition module. The cranking vacuum is 3 inches, which is about right. When you're spinning it over, the cranking vacuum ought to be 2 to 3 inches or something like that. That's something a lot of people don't even think about checking. The cranking vacuum is important to check. After a lot of brain torture, this was this guy talking, we discovered the electronic spark timing in the ignition module does not function during open loop. The original problem was the car was traded in this condition. Prior shop had replaced everything but the kitchen sink. Now what we got here, in addition to everything else, like on the most of the vehicles, I mean just about all of them, when you spin it over, they've got to retard the timing automatically so that it won't kick back. Because if the timing's advanced, even electronically or anything else, they're going to drop back to base timing. And if this one here was this one here, it sounds to me like the timing was not dropping back to base timing when they started. See what I mean? And so that's what's going on there. In the end, it proved to be the new ignition module that was installed was bad, but never gave any codes. The scanner showed electronic spark bypass functioning, but that was not switching internally, and the module did show some switching on the scanner. See, the scanner was indicating that we had some switching of electronic spark timing. And you know, you can see that I mentioned it later, but replace the ignition module with a GM module if cars running properly. Sometimes the aftermarket ignition module will be the problem. When I was working at the Ford place, if I saw a TFI module like this one right here on a vehicle that was running bad and it was some aftermarket brand, I don't care whose aftermarket brand it was, the first thing I'd do was jerk that off and put a Motorcraft module on it so I would eliminate that. Because one day I worked on a Bronco that had a brand new aftermarket module on it for a half a day until I finally realized that this module was causing a problem, and when I put the Motorcraft on there, it fixed it. And so there's some things you just need to rake off the table right to start with. You know, I don't trust that module, I put another one on it, you know. And most of the time it would fix it. With all due respect to the people that make Bosch spark plugs, those Bosch Platinum spark plugs, if I saw one of those come in there in a Ford and it wasn't running out, I'd jerk them things out and put, you know, Motorcraft spark plugs in it before I did anything else. You know, start out with the foundation before you go up with the house. Technician A says a compression test can be used to test the condition of connecting rods. Right? Technician B says the cylinder leakage test fills the cylinder with compressed air, and the gauge indicates the percentage of leakage. Who's right about that? That's going to be the connecting rods. You ain't going to, you know, find out anything on those. Okay, here's a 1998 Ford Expedition 5.4 liter, 135,342 miles. Idles too high. Engine idles at 1500 cold and 1900 hot. That's too high. IAC counts are at 75 to 80 when it idle. That's too high. Fuel trims are neutral. Doesn't have any kind of vacuum leak, right? If the fuel trims were out of kilter, if the fuel, which way would they go if you had a vacuum leak?
Like this.
They go forward. I mean, they go plus. They go, you know, added. Okay. He inspects for vacuum leaks, didn't find any, checked for stuck open, closed PCV valve. Nothing wrong with that. See, PCV valve can pull too much air through there. But if it's metered air, it won't affect the fuel ring. If I use the special functions on my scanner, the IEC counts drop to 40 as a starting point and the vehicle idles at about 750. Well, he can actually control this idle air control and bring it down and make it idle at the normal speed. So this is not a mechanical thing. Sometimes when I'd see one that was idling too fast, if I wanted to see if it was an air leak and I wanted to do it really quick, I'd take those hoses off. You know, you unplug the mass airflow sensor and it takes it out of the loop, and then pull those hoses off and crank it up and let it run on an alternate. And I would cover up with my hand, I'd cover up the throttle body hole where it had to, you know, if there was air coming from somewhere else, it would keep running. But if I covered it up with my hand and it tries to suck my hand in there and it dies, I know that it's not pulling air from anywhere else. That's just fairly common, you know, occurrence there. If I command AV counts, I'm idling at 1900 just like the vehicle and I see under PCM control. Check the throttle, it's not stuck open and the TPS value is at 1 volt DC and idle. I'm at a loss as to why the PCM is commanding such a large IEC opening. We talked about this in a war story last semester. Anybody remember it? The Ranger that was running away, right? One of the PIDs he wasn't looking at that was really important was the one that says closed throttle or part throttle, CTPT. All right. Even though the TPS voltage was within the range indicated for idle on the pinpoint test chart, which a pinpoint test chart is sort of like a crutch. I mean, You know, you gotta understand how this kind of thing works, you know, and what goes on is when you turn on the key, it pegs whatever it sees that the TP sensor is idle. Anything it sees above that, the rest of the time you're driving on that cycle, it's gonna call park throttle. That's what the deal was with that. He replaced the TPS and the voltage is still the same at 1 volt, but the engine now idles down and the scanner displays idle. See, what this guy didn't know when he wrote this in is the fact that his TP sensor, whatever you see when it turns it on, whatever the PCM sees, it pegs that as idle. And it may not even be the same thing every time, but it has to go back to that base voltage, closed throttle voltage, before it's gonna come off of that dash pot function. If it thinks it's still at park throttle, it thinks you haven't let completely off the gas. Dash pot function lets it come down slowly, and it holds it up there whenever you're, you know, at park throttle. A lot of people want to know about that. Here's a Chrysler that cuts out. This is the LXI 3-liter mileage, 98,045 miles, cuts out. All right. So this guy performs the lab scope testing and confirmed the synchronization of the camshaft sensor and crankshaft sensor. Didn't agree with the Mitsubishi published waveforms. The published waveform for Mitsubishi, they give you those things for a reason. If you're just looking at a scope pattern and you don't know what the right waveform is, that's why Matt has got a waveform library that he's building himself. You know, that's what he was telling me one time. He's building a waveform library so he'll have something to compare stuff to. I don't know if he's still doing that, but he was to start with. Because he's got a Pico scope like the one we got out there. Now, I removed the timing covers and confirmed that all the timing marks on the new timing belt were correct. So the new timing belt lined up. Remove the reluctor / crankshaft pulley assembly. Reluctor is the little toothed wheel that goes by the sensor, right? And that the reluctor plate had not moved on the 2 very small dowel pins that keep it aligned. So it hadn't moved. Good on that. So if you run into problems, somebody trying to mix up 3-liter Mitsubishi parts on this 3-liter Mitsubishi Chrysler conglomerate. So if you feel like, well, it's Mitsubishi, it ought to work either way. See, this is Chrysler, Mitsubishi, and then there's Mitsubishi. And they're both 3-liter, so this ought to work. If I were to replace the timing belt, crankshaft, pulley, reluctor, and this piece of trash Chinese distributor, it was a Chinese distributor that, you know, somebody bought from the parts store. I'm betting the car would be fixed. Unfortunately, those parts would cost around $1,800 from the dealer. So, an OEM distributor fixed the car. He started out by just replacing the distributor. Just popped the distributor on it. The difference between the optical plate between all the aftermarket supplied distributor assemblies and the one ordered from the Dodge dealer were incredible. They were all different.
So one of them that got the sensor in there?
Yeah, it's got an optical sensor in it. It's got a little blade in there that's got you know, emitter and detector on either side of it. It's got one of the slots that pass between them things, and that's what gives you that. And that's a pretty cool little fix there. 98 Chevrolet S10 LS 4.3 liter. Mileage 165,547 miles. It surges and cuts out. So he's tested fuel pressure. Now this is the CSFI system that's got the spiders under the intake. What I like to do with those is I like to put the electronic replacement for those under there because it works so much better than them stupid poppets. Runs like a top with no codes. The only time it acts up is in first gear. The only time it acts out is in first gear. Got it? When you punch it from a low speed, it's like the rev limiter is activating. It doesn't do it in any other gear. Rev limiter sounds like what?
Governor.
Wum, 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 wum. You ever see that?
But is it hitting red one?
It acts like it in first gear.
I mean, it could be slipping.
It just acts like a rev. Put it too low of an RPM probably. You know, I mean, I actually saw an Explorer doing that one time. It would, when at about 4,000 RPM, it would act like a rev limiter. It was dropping the coils out. And that one turned out to have a bad engine wire harness, you know, because it was under warranty. The problem with the intake air tube, between the body and the mass airflow tube was cracked, the throttle body. Under the hard load, it would flex enough to open up and the mass airflow would go crazy. Ran the truck with the mass airflow unplugged to narrow the problem to that area. There are times, and this one here was an air leak in that tube right there, you know, that air inlet tube. And that's fairly common because over time they get hard and they'll split. And when it opens up, suddenly you got a mass airflow leak and it starts to line it as the engine, you know, rocks back and forth. It does that. But I've actually seen, there was a Pontiac Aztec we worked on, and this thing would not drive over 50 miles an hour. It would accelerate to beat the band up to 50 miles an hour, but all you could get out of it was 50 miles an hour. And I noticed that the mass airflow sensor couldn't read above about 2.5 volts. Or about half, it was reading about, you know, it would read up to about half and it was like it was hitting a brick wall. And so I unplugged the mass airflow sensor and it ran like a race car. What does that tell me? In that particular case, it told me I had a bad mass airflow sensor. I've seen that on Chevys, on GMs, and I've also seen it on Fords. Maybe other vehicles have done it too. So the mass airflow, whenever you unplug that and it was no longer using mass airflow and it had to shift over and start using MAP and other things, it didn't know about that air leak in that case. The mass airflow is really important. We're going to talk more about mass airflow tomorrow. All right, what else you got? You got a story? You know that one? I got lots of stories. All right, so tell me something you learned.
Oh, I do got a story.
You do got a story, all right?
That Challenger that I
Yep.
built.
Yeah, the Challenger you built? Yeah.
Yeah. So the intake, the old intake where the throttle body come off, like it come back like this and it turned and kicked to the side, and it's got a pro charger on it. So obviously it's got a boost too. Well, when we put the new intake on, it's for a different motor. But it's the motor we put in there's been stroked out and all. So they put for the bigger Hemi, they put that intake on. Well, it's just straight coming back off of it anyway. So I had to rebuild the tube. Well, there's another dude helping me do it. And because we was all trying to figure it out, getting it done real quick so Matt can get the tune, because they was going to try to race it Friday, but they didn't get to do it. Anyway, the dude that was helping me do it pushed the hose up in the boot too far, and it wasn't letting the throttle plate rock back and forth.
Oh,
Yeah.
that's bad news.
And
Mechanical fouling.
and I had to cut the wires on the throttle body because when we changed the position of it, the wires had to be longer. And Matt's like, oh, you didn't hook that thing up right. And I took and unwrapped it off, traced all the wires back, we was standing there, I was like, it's hooked up right. And I was like, wait a minute. So I popped that tube off and I was like, I bet you a crank now. I got in the car and because it's one of them stupid push button ones, and pushed the button and hit the accelerator pedal, and he said a flat sitting there moving, the car turned right up.
So you shoved the tube up in there far enough to where the throttle plate wouldn't move. Outstanding performance. That was a good story. And then, but he was actually